Welcome to solverfy.
So it's a little unclear what our function is here, but it appears to be v of t equals 241.076 sine of t. So we're just going to go with that. And that's the value of the portfolio. We corresponding with t equals 0 in years. We want to determine the instantaneous rate of change in January 1st, 2012. So that's going to be 2 years after 2010, which is when we're initially starting. But it's the instantaneous rate of change. So we need to find v prime of t, which is going to be 241.076 cosine of t based on the given model. So after 2 years, we have v prime of 2 is going to be, again, we have, since we took the derivative, it's going to be 241.076 cosine of t. Replacing t with 2 now, we get a negative 100.32. And we want to make sure that our function's in degrees, or in radians and not degrees. Then, if we want to know the second derivative, well, v double prime of 2, v double prime of t is going to equal 241.076 times the derivative of the cosine of t, and we know the derivative of cosine is going to be a negative sign. So we're going to have negative times the constant times sine of t. And then we can calculate v double prime of t, v double prime of 2, which is going to give us a negative 219.2. So what this tells us is that not only is the value declining, but the rate at which the value is declining is decreasing. So the value function, for example, would look something like this. It's decreasing, but the rate at which it's decreasing is decreasing, so it's actually the rate at which it's decreasing is increasing. So not only is it decreasing, but it's actually decreasing at a faster rate because it's not only decreasing, but it's also concave down. We see that this graph right here is going to be concave down. That tells us a lot about that's a bad sign for the value of the portfolio.